Hi, this is Hai Xiaowang, and today we're going to talk about the palindrome linked list. And for this question, it tagged as easy, but I think um, if you try to solve this problem, use a really tricky method, and it can be medium. Uh, by tricky, I mean you can use uh, concept of the slow pointer and the fast pointer to find the middle of the linked list, and also reverse the linked list when you move the slow pointers, and then you can just solve these problems by only use the constant space. The brute force here is just use a list to store the every node informations and just check whether it's equal to the list when it's got reversed. And in that case, space complexity is just equal to the big O of the n. So let's talk about the smart method here. And we will use the two pointers, slow pointer and fast pointers. Fast pointers means the two steps in iterations. And because the basic idea is that we just move the slow pointer and the fast pointers, and once the fast pointer reach to the end of the linked list, the slow pointers get the middle of the linked list. And when we move the slow pointers, we should try to reverse the latter part of the linked list, and then we just compare the left part and right part and to check whether they are equal in every node, because we already reversed the left parts. So I hope it makes sense. Um, Actually, we use three variables. One is a slow pointer, one is a fast pointer, and one is a prev, which is a variable denotes for the previous node before the slow pointers. So here there are two cases. One is linked list has even length, and one is the linked list has odd length. So we start from the even length. So when we move the slow pointers, the finest point gets to 3, and we try to move this to 3. The fast pointer is points to now, and we just stop it. And here we already I already made these transformations here. So actually there is a prev, which means so we just start from compare the prev and the slow pointers, and the prev moves to right and slow move to right, and compare with whether they are equal. And if it's yes, we just continue, and if not, we just return false. And this is the first case of this problem. And in this problem, we stop the while when the fast pointer is removed to now. And the second case is all length. So when as slow pointer move to 2, fast pointer get to 3, and one so slow pointer move to 3, fast pointer get to 5. And we should stop here, and because it's equal, it's all length, so we do not consider the middle one. So actually here the prev is at here. Actually we should compare the 2, 1 and 4, 5. So here we should move the slow pointer to right, and then we just start our comparing. And in this case, the fast pointer is pointed to the 5, which means that it's not empty. So only when the fast pointer is not now, we should move our slow pointers. And that's it. We just start to code it and put set to be now, and allow the fast and fast .next is not empty. First, we should move to our fast pointer, because we are trying to change the rest of the linked list. So we should move the fast pointer first, and this is just a template of the reverse linked list. And if fast is not empty, which means that we are at all the ends of the linked list, so we should not consider the middle one and move to its next. And while play, if slow double is not equal to pre double, which means that it's not our palindrome linked list, which is return false. Oh, what? How? In else, we should move the slow next and pre is equal to pre next and return true. I hope it works. Yeah, that's pretty much about these problems. Thanks for watching.